We are going to take another look at graphing, and we are going to look at histograms and circle graphs. Before we do that, you should take a look at your grain sheet because I want to highlight a couple things here for you. We've already discussed the fact that you're always going to need a title. It's one of the most commonly missed points on tests, quizzes, etc. It's forgetting a title. Number 2 might seem like it's kind of confusing too. We have talked about this a little bit when we talked about graphing lines. And it's important that we put our independent variable on the x-axis. When you're forced to think about which is going on x and which is going on y, think about which constraint depends on the other one. The length of time it takes me to get somewhere might depend on my speed. So in this case, time might go on the y-axis. You have to be careful to always be considering those variables. Of course, we're going to label both the x and y-axis. We need to give a unit to each of those, and we talked about that a little bit yesterday. The fact that you need in inches or degrees Fahrenheit or dollars or thousands of people. We're obviously going to plot our points correctly. This is very important too. We have to give equal value to each space on the x and y axis. The only exception to that is when you're going to use your lightning bolt here. And you might say, okay, I'm going to go all the way up to 100, and then I'm going to go 110, 120, 130. I can use this lightning bolt to represent one break in my scale. So that talks about number 7 also, that I need to scale things properly. The next point is to use the appropriate graph, and this is what we're working on all this week. We need to make a key if we have more than one set of points, and we increase as we go from left to right. So that's just a reminder of some of the things you need to keep in mind when you're creating graphs. Let's take a look first at histograms. Histograms at first do appear very similar to bar graphs. And the difference is we don't have a space between the bars, and we display intervals of data. So each individual piece of data is not going to be displayed. It's only going to be grouped in with similar pieces of data. And our intervals have to be evenly spaced. So I really want you to think about this interval part for a minute. Okay, intervals are things like, let's say I'm going to go from 10 to 14. How many pieces of data fit in that? Well, 10, 11, 12, 13, 14. This is 5 pieces of data. I cannot start my next interval at 14, because if I do, then where am I going to put the value of 14? Which interval would it go in? I need to start with the next consecutive number, and then it needs to be as evenly spaced. So 15, 16, 17, 18, 19. And the next one would be 20 to 24, etc. This is very, very important. You can't have 10 to 14, 15 to 16, 17 to 25. Not allowed. You should use histograms when there are widely spread out data that needs to be grouped. Example 1, create a histogram to display the following data. Follow the 10 commandments of graphing. First, you need to create a frequency table. And the frequency table is first going to talk about creating those intervals. So what you want to do is you want to locate your highest value and your lowest value. It appears to me that the highest value is 28 and the lowest value is 0. Now this is temperature, so it could have been negative. I want to think about how many intervals I want. You don't want to have 28 intervals. You want to create a span over the range of your data. It looks here like they want me to use 6. So if I divide 28 by 6, it doesn't go in evenly, right? I'm going to have 5 pieces of data, because 6 times 5 is 30, and then I won't use the complete intervals, and that's fine. So I'm going to go from 0 to 4. Then my next interval also has to be 5 units long. So it's going to be 5 to 9, 10 to 14, 15 to 19, and so on. The next thing you need to do is you need to tally each of the temperatures. And you should be able to do this. A tally, remember, is this thing. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, etc. So you should go through each of those temperatures and create a tally. go in order so you don't forget one, because if you go out of order trying to organize it before you tally it, you're probably going to forget one of the temperatures. Come back, check your answer with me. I've completed my frequency table, and this again is very, very important that this is accurate. If it is not accurate, the rest of your data is all garbage. So you need to take the time to make sure you have the correct number of scores. So you might want to add up your total number of scores and make sure that it matches the number of scores here. Anything that you can do to make sure that this information is as accurate as possible is going to help everything else later on. So now we go down and we create the histogram. You will need a title and labels, and we graph the bars next to one another. So I'm going to label this with the town temperature on February 1st. I will make my horizontal axis. They're going to be my temperature intervals, remember in units, degrees Fahrenheit, and the number of towns that had those intervals. So this I'm going to label from 1 to 7. 7 was the highest number of towns that had a particular interval. So I've got to go at least up to 7. And then my intervals are going to go along the x-axis, 0 to 4, etc. So you can go ahead and do this, and then you will create your bars. So between 0 and 4, there were 4 number of towns, and I can just create it like that. So you can finish this on your own and come back and check. Here's my frequency table, and here is my histogram. We can now go to the back and create a histogram for the following data. You should first create your frequency table and then come back and check it with me. And then second, create the histogram and come back and check it. If you look at those quiz intervals, the highest score was a 20 and the lowest score was a 14. So I want to create 4 intervals between 14 and 20. In this case, I'm only going to have 2 data points within the interval. So you can go ahead and pause here and do the rest on your own. If you want to just check your frequency table here, and that's as far as you got, here's what I had. There were a total of 21 scores, and I made sure that that matched here with 21 scores. So if you haven't done so already, why don't you create your histogram? Okay, so my histogram is here. I have the title, I have labels on each side, frequency, but the number of students that got those particular intervals, and that is my graph. Now you could do number 3 on your own, and then again come back and check with me. If you just want to check that frequency table, you can check that here and then pause to make sure that you got the data correct for the histogram itself. If you've already done your histogram, then you can stay with me and we will reveal that in a moment. My histogram looks like this. Hopefully yours is similar. Alright, circle graphs. We use circle graphs to compare parts of the whole. Keep in mind that it needs a title. We put the percentages in the section. Students often put numbers or other things there. And they go along with the label of whatever they pertain to. If we look at the table, it's going to organize all these students into their grades and the number of students that got A's, B's, C's, D's, and E's. You can fill this in. We had 90 A's, 252 B's, 81 C's, 18 D's, and 9 E's. You would want to add that up and make sure you get back to that 456 graders. Okay. Then we create a fraction here, and this is one of the few times that it's okay to leave these non-reduced fractions, because if you fill this out, you want to make sure that you get 450 out of 450. The benefit to reducing it is sometimes you will know the percentage, and I'll show you what I mean in a second. So this is 18 out of 450 and 9 out of 450. Now, if I reduce that first fraction, it's 1/5, and that's a common percent to me. I know it's 20%. So that's the benefit of reducing it. Then this is a key component again. You have to then take fractional part, or the percentage of the degrees in the central angle. Well, that's a proportion to 360. In other words, 1 is 2, 5, as x is 2, 360. What part of the circle is 1/5? And if you figure that out, or you can likewise take 20% of 360, you would get 72 degrees. So why don't you go ahead and fill out the rest of this table for me and come back and check. Here's the table completed, and you should see that your percents add up to 100. Sometimes you might get 101 or 99 because of rounding. I suggest you don't round, you keep it to the 10th if you need to there, and the same thing with the degrees so that they add up to 360. And then when you measure it out, you can kind of round it there. The first thing that you're going to do is create just one line segment from the center to the edge of the circle. And then you're going to create angles as you progress around the circle with a compass. So the first angle I'm going to make is 72 degrees. I would get a compass and I would go ahead and measure out 72 degrees. Okay, so I'm going to measure out 72 degrees. I'm going to put a little dot right there by 72. There we go. And then I would move my compass out of the way and I would create another segment. I'm going to do that all the way around my circle. Now the more precise you are, the better it's going to work for you. I know that this segment is A's, and that's 20%. Some of you might like to label it as you go around so that you don't make a mistake. Then I would move my protractor back. I would create the next angle, 202 degrees. My protractor doesn't go to 202 degrees. So I can mark off 180, and then I can bring that back around to 180 and subtract 180 from 202, which is going to give me 12 degrees. So you guys should be able to do this on your own and come back and check that your graph looks like mine. Now this should be the final product for your circle graph. And if you look closely, look at mine and compare it to yours. There are several things you should be looking for. First and foremost is a title. Secondly, make sure that you have the appropriate percents associated with each of the sections. We put the percents there, not the number of individuals, not the fraction, not the degrees. And you could have these colored. It makes it look a little nicer. If you decided to do that, that would be a good idea. We have another circle graph here, and I think it would be a good idea for you at this point to at least complete the table. Then you can come back and check your table and make sure that you have all the correct degrees, etc. And then if you want to break it up into two sections, create the circle graph after that. With the exception of the number of candy bars, I didn't fill out that column, and I apologize because there were not enough rows for the number of categories, but you could squeeze it in somehow. So these are the appropriate percentages and degrees. You should check those and make sure that you agree with me before going on. Now, if you rounded here, you may have not added up to 360, and also you may have not gotten 100%, which is why I said not to round really until you go ahead and do your graph. So if your table's all set, you can pause here and create a graph. And here we have our circle graph relating to the favorite candy bars among 700 BRMS students. Notice the title, notice the percentages. I didn't color mine in, but maybe you did. So that's circle graphs in a nutshell. We'll have more practice with this tomorrow, so enjoy your evening. I'll see you then.